Alright, so today we are going to graph hyperbolas. So hyperbolas are two parabolas that go opposite direction. So we have these two for our formulas. So this guy opens left and right, and this guy opens up and down. So basically your parabola is going to look like this. So for example, let's say we have this guy and this guy. These are really bad. And then these ones open left and right. So like this and like this. Okay, then we have a center. So the center is like in the center between, this one looks a little off, between the two of them. And then we have our focuses, or our foci are in here. So there's our focuses. Then we have these asymptotes. So these asymptotes kind of go like this, and like this, and like this. It's a bad one. And like this. They have to go through our center. So let's make our centers a little bit bigger to make it match. Okay. Like that. So the edges of our parabola are forever getting closer and closer, and they actually go out a little bit more like this. They go closer and closer next to our asymptotes, but they never touch it, because an asymptote is just something that you get closer to forever, but you never touch. So this is a hyperbola. You either have the up and down ones or the left and right ones. Now there's distances from like your vertex to vertex, so from here to here. And then if you look up here, that's what these names are, the transverse and the conjugate. So the transverse axis is parallel to the x-axis, so that means that it's going this direction. So this is transverse. And basically what we're doing is we can make a little box right here, which we'll talk about more, and that helps us get some measurements. And then the same thing for the conjugate is the y-axis. So that means it would be from this vertex to this vertex. So that is 2a and 2b, okay? So similar to what we did for our ellipses. And then over on this side, it just looks a tiny bit different with the formulas. Notice that my y is not first on each of them, and my x is not first on each of them. So my x is first over here, and then my y is first over here, and they switch, but a and b still stay the same. They're both subtract, whereas in the other problems, we had some add. So if you look at ellipses, they're add, but hyperbolas are subtract, and they are equal to 1 as well. So again, the parallel to y-axis, so the y goes up and down, so this is the A, this little part, and this is the transverse. And then parallel to the x-axis right here, so that would be from like vertex to vertex right here, that is the conjugate. All right. So there's some background information for you, and we'll use this more tomorrow. All right, so here we go. Number 2. So first we have to figure out what equation we're dealing with, and since the y goes first, then we're looking at this guy, and it's going to open up and down. Okay? So we're going to write our center, and our center is at h. Well, and look, this one's backwards. So it's kh, so it would be 0, 0. Okay, hold on. So just be careful on that. So we have our center. Now we're going to get our, we should graph it, 0, 0. We know our A is 4 and our B is 2. So we can get our focus, or foci. So our foci are H, K, minus C. Oh no, we should get our C. So our C, we're going to use this relationship, which is slightly different than all the other ones, because, of course. So it's C squared equals A squared plus B squared. So C squared equals 4 squared plus 2 squared. So C equals the square root of 16 and 4, so 20. And then let's get the decimal. So 4.5. Okay, so minus, oh right, where are we? We're here. Minus 4.5, and then we have 0, 0 plus 4.5. So my focus are at 0, negative 4.5, and 0, 4.5. So 0, negative 1, 2, 3, 4.5, and then 1, 2, 3, 4.5. And then we need to get our vertices. Oh gosh, I hate spelling that word. Okay, so our vertices are our H, and then our K minus A, and A is 4. And then I have 0, 0 plus 4, so this is 0, negative 4, and 0, 4. 1, 2, 3, 4, and then 4. Okay, then we need to figure out our asymptotes. So we need to do that. So it's y minus k, which is 0. And then we'll do the positive version first. It's a over b, so 4 over 2, times x minus h, which is also 0. So y equals 4 halves, so 2x. And then it's the same thing, but my this guy is negative, which really makes a difference if you have like extra numbers here, but since we don't, it's going to be y equals negative 2x. Then we graph that line. Okay, so here we're going to start at 0, 0. We're going to go up 2 into the right 1, 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 and then down 2 into the left 1, 1, 2, 1, 2, 1, 2. So this is one of our asymptotes. And then we have to go the other way, up 2 over 1, all the way across. We're going to make it so pretty. Down 2 over 1. Oh, that line is a little wiggly. So this is our focus, and this is our vertex. So it kind of looks like this. This is our hyperbola. It should get a little closer on the line, but it never touches the line. Like that. And we have now graphed our hyperbola. Okay, so let's talk about the transverse and the conjugate axis. So for this one, the transverse axis is parallel to y, so it's going to go up and down, and it's 2a. So a is 4, so that should be 8. So counting from vertex to vertex, it should be 8. 1, 2, 3, 4, 5, 6, 7, 8. So there we go. Then the conjugate axis is 2b, so that should be 4. So from the center, it's 2 each direction. And then that helps us draw this like boxy looking thing, which you may see on some parabolas. This thing right here. Anyways, there it is. And that's what the conjugate and the transverse axis are. So let's do another one. A number 4, because it doesn't say 1, the first thing that we need to do is divide everything by 4. Okay, and then you simplify. So the first one is y minus 2 squared over 4, and then 4 and 4 make 1. So minus x plus 2 squared over 1, and then 1. This is actually a quiz question, so I'm going to skip that and let you figure it out from there. Okay, then we're going to look at number 6. Again, there are coefficients on these. We want this number to be 1, so we're going to divide everything by 28. And that should give us some perfect squares. So, oops, heavens. 7/28 reduces to 1/4. So we really have x plus 4 squared over 4 minus, and then 4/28 is 1/7. It's not a perfect square, but we'll be okay. Y plus 2 squared, it'll just be a little bit more complicated, equals 1. Okay, so there's that. So we have x first, so this time we're looking at this side. So that means that our parabola are going to open, oh, left and right. Oh, shoot. At the very beginning, I done messed up on these. I'm really sorry, but I do not want to go back and record it. So these need to switch spots. My bad. Okay, number 6. So we're going to open left and right for this guy because x goes first and so does x over here. Okay, so we need to figure out our center. Our center is HK, so we just read our center and our problem together. So our center, and it's opposite again, so -4, -2 is H and K. So that's our center, and we're going to graph it. -1, 2, 3, 4, down 2 is the center of our hyperbola. So our two asymptotes are going to go through that and make an X. All right, let's brighten that up. Okay, now we need to figure out our A and our B. So on this problem, A is on the first side, so our A is going to be 2, and then our B, well, 7 isn't really pretty, so we're just going to write the square root of 7. We're just going to leave it like that for a second, and then we need to figure out our C, because we can't do the rest of this without C. So our formula is C squared equals A squared plus B squared. So our C squared is in front, A squared is 4, and B squared is 7, because the square root of 7 squared is 7. So C squared equals the square root of 11, which is 3.3. So 3.3. All right. So now we can figure out the foci. So our foci are going to be H minus C. So H minus C, and then K, and then H plus C, and then K. So we have -7.3, -2, and then we have -4 plus 3.3, oh no, is -0.7 and -2. Okay, so -7.3, 1, 2, 3, 4, 5, 6, 7, and then 3, and then 1, 2, so here. And then this is -0.7, 1, 2, so there. So those are the foci. So now we need the vertices. So vertices are H, -4, minus A, and then K. And again, -4 plus 2 minus 2. So we have -6, -2, and -2, -2. So -2, -2, -2, 4, 6, right, 1, 2, 3, 4, 5, 6, -2. So there's our vertices. Okay, now we need to figure out our asymptotes. So y minus k equals b over a times x minus h. Oh, let's move it like that. And then we're going to do this again, but we're going to have a negative. So we have y plus 2 equals -7/2 x plus 4. Okay, so we distribute this guy to each of those, and then we're going to subtract off 2 on each side. So y equals the square root of 7/2 times x. And then this one is just not the most fun. 7 over 2 times 4 minus 2, and that is 3.29, 3.3, and 3.3. So then for this guy, underneath, actually, just redo this one and insert negative here. K times 4, and then we minus 2, and that gives me negative 7.3. So y equals negative root 7 over 2 x minus 7.3. And the square root of 7 is 2.6. So that's my slope of my line. So a rise of 2.6 and then a run of 2. So for this guy, I'm going to start at 3.3, all these decimals. 1, 2, 3, and here. So I'm going to start here, and then I'm going to go up 2.6 and over 2. So going up 3.3 plus 2.6 is almost 6. And then over 2, we're going to call it that. And then I'm going to go up 2.5, and then over 2. Okay, and then 3.3 minus 2.6 is 0.7. So we're going to go down to 0.7 and then over 2. And then it should go in the center, so we're just going to skip that. And then from here down 2.5 and over 2. And then that'll be close enough. I'm done trying to figure out that guy. There's 1. Okay, then we're going to start at negative 7.3. 1, 2, 3, 4, 5, 6, 7 in a little bit. And we're going to go up 2.6. So negative 7.3 plus 2.6 is negative 4.7. 1, 2, 3, 4.7. Yep, that's right. And then over 2. Sure. And then it has to go to the center. And then up 1, 2.5 over 1, 2. Again, I'm done with it. That is close enough, friends. So there's our asymptote lines. And then we can draw our hyperbola. Goes like that, and then like that, and then like that. It's not that curvy at the point, but whatever. There's our hyperbola. That one was beastly. Okay, let's do one more. We're going to do number 8 or number 7. Either way, they're both nice, so I don't care. Let's do number 8, because the y is first, and that one is weird. So we're going to divide each of them by 4. So my formula is y squared over 4 minus x plus 1 squared over 4 equals 1. Okay, and this one I'm looking at this side because y goes first. So remember, it's k and then h. But we write our center as hk. So our center is negative 1, 0. And then we need to figure out all the other business. So negative 1, 0 is here. Our a is 2. And our b is 2 as well. So our c squared equals a squared plus b squared. So c squared equals 4 plus 4. C squared equals the square root of 8, which is 2.8. So that's our C. Okay, so then we're going to figure out our focus, and that is H, which is negative 1, and then K, which is 0, minus C, so minus 2.8, and then negative 1, 0 plus 2.8, so negative 1, negative 2.8, and negative 1, 2.8, so negative 1, 2.8, and negative 1, 2.8. Okay, so those are our foci, vertices. Our vertices are h, which is -1, k is 0, minus a is 2, and then -1, 0, plus 2. So -1, -2, -1, 2, -1, negative... Oh, I did this wrong. 2.8 is up here, and this guy should be there. This guy should be there, and -2.8 is there. There we are. Okay, then we need to figure out our asymptotes. So y minus 0 equals 2 divided by 2 times x minus h. Okay, and then we have the same thing again. Y minus 0 equals -2/2 times x plus 1. So y equals 1x plus 1, and y equals -1x plus 1, because -2/2 is 1, and 1 times 1 is 1. These are much easier to graph. Okay, so up 1, and then up 1 over 1. Again, notice they go through our center, down 1 over 1, which is what they're supposed to do. And then I can also go up 1, and then... Wait, what? Yeah. -1. My bad. I didn't distribute the negative here. Like, this is not working. -1, there we go. Up 1 over 1. All these little details. But if you have an idea of how they're supposed to look and you start messing up, then you can figure out how to fix it fairly easy. And then my hyperbolas are like that. Close enough. All right, let me know if you have any questions. Have a great day. Bye.